Today's question: three rods made of the same material and having the same cross section have been joined as shown in figure. Each rod is of same length. The left and right ends are kept at 0 degree centigrade and 90 degree centigrade respectively. The temperature of the junction of the three rods is. So this is the given figure. So left side we are having a temperature of 0 degree centigrade, whereas the rod end and the right side both are having a temperature of 90 degree centigrade. And we have to find out the temperature of the junction. Let us call this temperature of the junction as Tj. So in order to solve this, we are going to use, Fourier law of heat conduction. Fourier law of heat conduction. And this law gives us the rate of heat transfer. You can say the rate of heat transfer which is represented as Q through a rod it is given as Q is equal to Ka temperature of hot junction minus temperature of cold junction and divided by length of the tube, length of the rod. Herein our Q, so Q we already defined, let us define as K. K is thermal conductivity. Thermal conductivity. A is the area of cross section. Area of cross section. L is our length of the rod. Length of rod. And T hot and T cold, these are the temperature of the end of the rod. Temperature at the end of rod. Now we are going to use another concept that is called as a heat balance at the junction, because incoming heat will be equal to outgoing heat. So we can say heat balance at the junction. Heat balance at the junction. And this heat balance is under the steady state condition. So we can say for steady state condition, the heat flowing into the junction must be balanced. Must be balanced. So which basically means the heat by the outflow of the heat from the particular junction. And we assumed that the junction temperature is Tj. We say junction temperature Tj is determined by the heat flow from the three rods. Heat flow from the three rods. And we have three rods, so let us assume that Q1 heat flow is because of the left rod. We can say Q1 is the heat flow from left rod whose temperature is given as 0. Let us call this as T left. And we have two rods on the right, and their both end temperature is same. So therefore you can say Q2 is equal to Q3, and this is our heat flow from right rod, and temperature, let us call it T right, is our 90 degree. Now we are going to use the Fourier heat flow equation for rod left and then for rod right. So you can say that our heat flow from left rod and we said that it is governed by Q1. So you can say our Q1 will be equal to Ka Tj minus 0 divided by L. Now similarly, for our right rod, heat flow from right rod and left rod, let us call say rod 1, and right rod we have two rods, rod 2 and 3. So in this case Q2 will be equal to Q3, and that will be equal to Ka 90 minus Tj divided by L. Now we are going to use heat balance equation. Heat balance equation, which gives us that Q1 will be equal to Q2 plus Q3, and we can write this as twice of Q2 because Q2 and Q3 will be same. We substitute the formula for Q1. Q1 we have Ka Tj divided by L, and this is twice multiplied by Ka 90 minus Tj divided by L. Kal cancels out, so this gives us that our Tj is equal to 180 minus Tj, which further gives us that 3i's Tj is equal to 180, and we have that Tj will be equal to 60 degree centigrade. So this is the junction temperature. This is the junction temperature, and the options that are available with us, we can say option number B is the correct option. Option B is correct. So this completes the question. Thank you.